All right, we're going to start Chapter 8. This is Section 1, Geometric Mean. Is that when squares are jerks? It's when the means of a proportion are the same number. That number is called the geometric mean. The geometric mean is the square root of the product of the extremes. So when we do means extremes product here, when we cross multiply, we get x squared equals AD. And so then we would have to take the square root of AD to find out what x is. So the definition is, yes, I'll be in class in 10 minutes. The geometric mean of two numbers a and b is the number x such that a over x equals x over b, so that x squared equals ab and x is equal to the square root of ab. So let's insert an awesome geometric mean example problem here. All right, so first we want to find the geometric mean between 8 and 10. So it's going to be very simply 8 over x equals x over 10. We cross multiply, we end up with x squared equals 80. So the largest perfect square that goes into 80, so here's something that, well, let's do this part here. So we're going to take the square root of each side of this. And so we're going to end up with x is equal to the square root of 80, which can be simplified. So we're going to take, and the largest perfect square that goes into 80 is 16, so x is equal to square root of 16 times the square root of 5, and so your final answer should be 4 square root of 5. Okay, now we want to try to find the geometric mean between 5 and 45. So again, we're going to set this up as 5 over x equals x over 45. Now I end up with x squared equals, so x is equal to this, x is equal to the square root of 225. And the 225 is a perfect square, so x is equal to 15. Find the geometric mean between 12 and 15. So again, 12 over x equals x over 15. So x squared will equal, I'm going to show you a little trick here. I'm going to pull some of this apart, and you'll see a little trick to go here. This is equal to the square. So 4 times 3 is 12, but this is also 3 times 5. So I know that 3 times 3 is 9 there. So I have the square root of 4 times the square root of 3 times the square root of 5. So your final answer is square root of 4 is 2, square root of, nope, excuse me. Let me fix this. That should say 9. Square root of 4 times the square root of 9 times the square root of 5. So square root of 4 is 2 times 3 times the square root of 5. So our final answer is x is equal to 6 square root of 5. There should be a square root there. All right. Now, geometric mean in right triangles. If in a right triangle, an altitude drawn from the vertex of the right angle to the hypotenuse forms 2 additional right triangles, and these 3 right triangles share a special relationship. So if the altitude is drawn to the hypotenuse of a right triangle, then the 2 right triangles formed are similar to the original large triangle formed and to each other. So if segment CD is the altitude to hypotenuse segment AB of right triangle ABC, then triangle ACD is similar to triangle ABC, and triangle CBD is similar to triangle ABC, and triangle ACD is similar to triangle CBD. There we can see that the overlapping triangles, the 3 triangles, are similar. All right, let's insert awesome similar right triangle example problems here. All right, we want to write a similarity statement identifying the 3 similar right triangles in the figure. So the first one I always start with when I have to do this is the biggest one. So I'm going to go triangle FGH. Now that's going to be similar to triangle. And then the next one we're going to do, I'm going to take and do this one right here. So this one here that was blue, now that I've colored yellow, is the next one we're going to put in there. So that's going to be, now the F matches up to F. Oops, let's just do this back here. F matches up to F. G is the right triangle in the big right angle in the large triangle, so J has to be the right angle there. So FJ and then G is going to be similar to triangle. Now we're doing the same thing here. Since we'll go back to the first one, H is going to match up with H, so it's going to be last. J is the right triangle, right angle, that's the one in the middle. And then GJH. So there's our similarity statement. Okay. So here we're going to do the same thing. So you should probably practice along with me again. I'm going to take the large one first. So KLM or KML is similar to triangle. K again. P is the right angle, so that's going to go in the middle. And M is going to be the last one. And that's going to be similar to the next one is L is going to match up to itself, so L's got to go to L. I'm always looking at that first one. So L matches up with L. P is again the right angle, and M is the remaining vertex. Here we go, third time. Triangle. Let's go SRQ, right? So we'll put the right angle first. SRQ is going to be similar to triangle. I'm going to do the small one, okay? So the small triangle here, this one right here. So triangle SRQ angle T is the right angle in that triangle. R is going to match up to itself, and then S, and then that's going to be similar to triangle. And we're going to do the right angle first, T. Q matches up to Q, so Q is the last angle there, so TSQ is the last triangle. Okay, and I have no idea why this is here yet. Oh, I do have an idea as to why this is here. In this situation, you're going to notice that we have some various measurements, right? A, B, and C are these two large, are all the, so here we have A, we have B, and we have C. And we know by Pythagorean theorem that A squared plus B squared equals C squared. In this triangle here, we're going to have H and X, and then B is the hypotenuse there, and then H and Y and A is the hypotenuse in this one right here. Okay, so we can see that the shorter leg to the longer leg with all three of these. So the longer leg is A, excuse me, the shorter leg is A, the longer leg is B. In this triangle right here, the shorter leg is Y, the longer leg is H. In this triangle right here, the short leg is H, the long leg is X. Now, if we want to see the length of the hypotenuse over the shorter leg, well, in the large triangle, it's going to be C over A. In this triangle right here on the right, if the hypotenuse is A, the short leg is Y. And in this triangle here, the hypotenuse is B, and the short leg is H. And one way to remember which is the short leg always, this angle is the smallest angle, so this is smallest, smallest, right? Smallest angle here, smallest side there. So if you guys can remember how that we learned that before. Last thing we want to look at is the hypotenuse to the long leg. So C over B in the big triangle, right? C is the hypotenuse, it's across from the right angle. B is the largest angle other than the right angle, so B is the longer side. So in this smaller triangle here, or we'll go with this triangle, B is the hypotenuse, X is the longest side. This triangle here, A is the hypotenuse, and H is the longest side. Now, what do you notice here? Geometric means occur in all three of these extended proportions. All right, those are geometric means. So, the geometric mean altitude theorem states the altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments. The length of this altitude is the geometric mean between those two segments. All right. So the height, or what we always say for the length of the altitude, is always the height. X and Y are the two segment lengths that the intersection of the altitude to the hypotenuse point D separate AB into. You'll notice x over h equals h over y, or h is equal to the square root of xy. To continue on with this, the altitude drawn on the hypotenuse of a triangle separates the hypotenuse into two segments. The length of a leg of this triangle is the geometric mean between the hypotenuse and the segment of the hypotenuse adjacent to that leg. What does that mean? Well, if segment CD is the altitude of to the hypotenuse segment AB of right triangle ABC, then C over B equals B over X, and B is equal to the square root of XC, or C over A equals A over Y, and A is equal to the square root of YC. So what we're saying here is this is the geometric mean between these two. And this is the geometric mean between these two. Okay, between C and Y. Okay, we're going to be taking these and doing a lot of practice. Okay, so here's something you may want to jot down. So H is the geometric mean. I'm just going to put GM between those two segments. Okay, see how it's between the two of them in the drawing. Okay, that's one way we can memorize this. Y is the geometric mean between these two. Okay, A over Y equals Y over C. Okay, that's the geometric mean to that side. X is the geometric mean between those two. Okay, so when you look at your diagram, you need to do some thinking and some figuring out and take some time to think about this. All right, don't rush through. Oh, that was weird. Okay, again, let's go through this, see what we can do with this. Hopefully it's not a repeat. I had a little technical glitch there. So X is the geometric mean between 5 and 20, so we're going to have 5 over X equals X over 20. That's going to give us 5x, oh, excuse me, no it's not, x squared, excuse me, x squared equals 100. We take the square root of each side of this, and we end up with x equals 10. Now, we're going to do, we have to figure out, first of all, the length of this hypotenuse. So that's going to be 25. So we know that 5 is the geometric mean between y and 25. So y over 5 equals 5 over 25. So we end up with 25y equals 25. Divide each side by 25. We get y is equal to 1. Right? So, that can't be correct. All right, next one. We're going to say that 20 is the geometric mean between 5 and, excuse me, the geometric mean between z and 25. So z over 25. Oh, excuse me. I'm being distracted a little bit here. We'll go again. Z over 20 equals 20 over 25. So we end up with 25z is equal to 400. So 25 goes into 400 16 times. Okay. Now, we could have reduced, we could have redone this as this is equal to 4/5. And feel free to do that if you want, so that you end up with the same thing, 5z equals 80. You still end up with the same answer there if you reduce beforehand. Okay, find x, y, and z. And you can do these in any order you wish, so you have to look at these. I am always a big fan of knocking, I'm going to always start there with the length of the altitude. And do, because you need, it blends into everything else really easily. So, I'm going to do is 8 over z equals z over 25. So this leads to z squared equals 200, which take the square root of each side, and that means that z is equal to 10 square root of 2, or the square root of 200. On the next problem now, x. So let's do that in a different color. So x over 8 equals, now keep in mind this whole length you need for this problem is 33. So x over 8 equals 8 over 33. So 33x equals 64. So if you make it 33 there, divide each side by 33 and you end up with x is equal to 64/33. Now we're going to solve for y. So y over 25 equals 25 over 33. Again, 33y equals 25 times 25, what does that come out to? 625. So x is equal to, excuse me, y is equal to 625 over 33. Okay. Let's take a look at these now. Now some of these you can use a little bit of foresight with to come up with some answers. I'm going to use the Pythagorean theorem to solve for this one right here. I already know, oh, I can actually do this. That's fine. I don't have to do that. I'm going to solve for x. So I know 12 is a geometric mean, so I'm going to say x over 12 equals 12 over 9. So now we cross multiply, we get 9x equals 144. And 144 divided by 9 is equal to 16. So if this is 16, the whole length of this now is 25. So now we can solve for the rest of this. Y over, if this is 16, you may want to label it here. So y over 16 equals 16 over 25. So 25y is equal to 16 squared, which is 16 times 16, which is 256. So I'm just going to say y is equal to 256 over 25. And that's my answer. Leave it improper. There's no problem with that. Unless if you have a multiple choice test, you have to convert it then. That's fine. Let's do another one. For z. So z over 9 equals 9 over 25. So 25z equals 81. So z is equal to 81/25.
You can.
That's awful.
I know that was long, but thanks for sticking with me.